Good morning, afternoon, or evening, cats and dogs. Today's video is going to cover the volume of prisms. We're specifically going to look at rectangular and triangular prisms, although we will see some other prisms that are not rectangular or triangular. We won't do volume of cylinders, cones, spheres, or any of those things, although you may see those in future years. Before we get into some of the formulas, I first want to state that volume is the measurement of the space inside of a three-dimensional figure. So it's kind of like area for a three-dimensional figure, since we're looking at the amount of space inside. This would be, for example, if we're looking for how much space is inside of a cereal box or an oatmeal container or something like that, to figure out how much is inside of that product. Now, for the volume of prisms, you're going to notice for the volume of any type of prism that we use capital B in that formula, and capital B is different than lowercase b. Capital B stands for the area of the base, while lowercase b just represents the length of the base. Perhaps in a triangular prism, the base of the triangular base. We're going to use that word a lot here. Let's start with our rectangular prisms because those are pretty straightforward, and the volume of a rectangular prism is just length times width times height. Now that is area of the base times the height, since the area of the base is length times width, and then multiply that by the height as well. But we just use the formula length times width times height. Now, like when we saw the perimeter formula for a rectangle, keep in mind that I know that L looks a lot like a 1, but that is an L, so length times width times height. Something also to know is it doesn't really matter what order you multiply those numbers in, so it doesn't matter which number you identify as the length, the width, or the height. Now, for the triangular prism, this formula was just updated in the current year, 2023-2024, and the formula for the volume of a triangular prism is half times the base, which is the base of the triangular base, as you can see in the figure here, times the height, which is the height of the triangular base, and times the width of the prism. And W represents the distance between your two parallel bases. They're actually going to call that H for a polygonal prism. We'll get to that in a moment. There are some extra letters in the picture shown on your formula sheet, and the reason behind that is we'll see that with surface area. Let me just highlight some of the things here as well, just so we can point out a few of the more important things here. So we're looking at base and height, something to keep in mind, and I know I put this in the description here. When we're looking at the base and height of the triangular prism, we're looking specifically at our triangular bases, which I'll go ahead and outline, at least this triangular base that we can see right here. And so when we're talking about the base and the height and height have to meet at a 90-degree angle, and I can see that 90-degree angle right down here. So I'm looking for that when I am identifying my base and height. Sometimes the base and height will actually be sides of your triangular base, both be sides of your triangular base. In this triangular prism that we have, the height is actually inside the triangular base. And we'll do some practice with this. There may be some extra numbers in the picture we won't need to use, so that's just something for us to be careful about. Now, for a polygonal prism, which you would use for anything that isn't a rectangular prism or triangular prism, the example that's on your formula sheet is a pentagonal prism. We are going to use volume equals capital B, which is area of the base, times the height. Now, here they use H to represent the height of the prism. We called that previously the width of the prism. I don't know why they're not consistent there. This is a PSSA formula, but the height is the same as the width. It's just the distance between your two parallel bases for a prism, because keep in mind, every prism has two parallel bases. We will give you the area of the base for problems like this for the most part, unless it's a shape that we know how to find the area of the base for, but we don't know how to find the area of a pentagon or a hexagon or an octagon yet. You'll see that if you take geometry, so we'll give you the area of the base in most cases. And then if we have a cube, I believe this is also on your formula sheet, the volume of a cube is just s to the third power. It's like length times width times height, but where length, width, and height are all s, so we'll just do s to the third power. And we can show you where to find that third power, or how to plug in an exponent other than 2 on your calculator as well.
Now, the formula for the volume of a cube, this might be on your formula sheet. I don't have it right in front of me right now, but it's s to the third power, since every side of the cube has length s, kind of like when we did squares, but that would be s times s. This is s times s times s, which is s to the third power. We will take some time in class and show you where your exponent key is again and how to plug in something to the third power. You can also use the length times width times height formula. It also works since a cube is a rectangular prism. All right, let's go into our exercise problems. Beginning with number 1, we're given a rectangular prism. The first thing that's important to do is identify what shape we're talking about. It's a rectangular prism, so the formula we can use is just length times width times height. Does it matter which one's your length, width, or height? It doesn't. You're just going to multiply them. So I took 4 times 3 times 6. Feel free to use the dot for multiplication. However, sometimes we have decimals as our length, width, or height, so that can get confused with the multiplication sign. 4 times 3 times 6 is going to get us a volume of 72 centimeters cubed. 72 centimeters to the third power. Kind of like for area, we had centimeters squared. When we did perimeter, it was just centimeters. For volume, it's going to be centimeters to the third power because 72 centimeters cubed represents how many cubes of 1 centimeter on each side we can fit inside of this rectangular prism. And in fact, we could fit 72 inside of this rectangular prism that we have. All right, let's take a look at number 2. Also a rectangular prism, but it's also a cube since all the sides are the same length. So I used s to the third power, which is 2.5 to the third power, and that gets us 15.625 inches cubed. Don't forget your labels. If you don't know how to plug in 2.5 to the third power on your calculator, definitely check in with me. But you can also do 2.5 times 2.5 times 2.5. So you can just multiply it that way, not 2.5 times 3, so be careful. Don't round your answers either. Sometimes I get asked by students, should I round it? It's a short enough decimal. Just write the whole thing. All right, let's move right ahead to number 3. Number 3 is also a rectangular prism. So we're just going to do length times width times height. Take 6 times 1.9 times 10. Here's a great example of where the parentheses are good for multiplication because 1.9 is a decimal. This is going to get us 114 millimeters cubed. So final answer, 114 millimeters cubed.
All right, so let's get into our volume of triangular prism examples here, which are 4, 5, and 6. So when we look at a triangular prism, keep in mind our formula is half times the base times the height times the width. So when I'm looking at my example that's typed up for us in between questions 3 and 4, I'm looking for my base and height. And remember, they're going to intersect at a 90-degree angle, which I can see right here in my triangular prism. So I'm going to let my base be 4.1 and my height be 3.2 since they meet at a 90-degree angle. The width of our prism here, again, is the distance between your two triangular bases. So that is going to be 8 inches. We don't need the 5.2 in this case, so we can ignore it. We would need it for surface area, but we don't need it here for volume. So once we identify base, height, and width, we just plug those into the formula. So it's half times 4.1 times 3.2 times 8, which gets us a volume of 52.48 inches cubed. And again, there are some reminders down here. We want to keep in mind that the base and height intersect at a 90-degree or right angle, so we want to look at that. I did note that 4.1 and 3.2 are interchangeable as the base and the height, since they each intersect at a 90-degree angle. Again, the width is 8 inches, since it's the distance between your two triangular bases, and I stated here that you do not need that 5.2 inches, since it's not the base, height, or width of the prism. All right, let's go ahead and do a few examples. So in number 4, we're looking for that 90-degree angle, which we can see right here. So when we identify base and height, we want those to intersect at a 90-degree angle. So our base and height will be that 9.8 and the 5. And then the width of our prism will be 4. Like the last example, you can see this is the same picture actually with different numbers. We do not need to use the 11 meters. So I'll just go ahead and reveal our base, height, and width. And then we're just going to plug those into our formula. So half times base times height times width. Notice how I always start by writing my formula. My base and height, I'll plug those in along with the width. That will be half times 9.8 times 5 times 4. Once I plug that into my calculator, I will get 98 meters cubed for my solution. All right, let's take a look at number 5. Again, we're looking for that 90-degree angle, which I can highlight right here in green. So our base and height have to intersect at a 90-degree angle. I'm going to use 26 and 28 as my base and height. The width of my prism is going to be 41. So this is an example, kind of like our last one, where we notice that our base and height happen to both be sides of the triangular prism, or the base of the triangular prism. I should be a little bit more specific. So when we go to identify base, height, and width, you can see I'll reveal that here. My base I made 26, my height 28, and those are interchangeable, and then the width is 41. So let's plug those into the formula. Volume is half times base times height times width. So we'll do half times 26 times 28 times 41. That will get us a volume of 14,924 meters cubed. All right, let's take a look at our last triangular prism. Now this one's a little bit different because our height of our triangular base is inside the triangle, but we see this 90-degree angle here, which indicates that our base and height will be 8 and 4, and then the width of our prism will be 15. So we do actually need all of the numbers that are provided here. And I'll go ahead and reveal the base, height, and width here, and let's slide this down. There we go. So the base is 8, height is 4, and width is 15. Same formula, half times base times height times width. We're going to plug those in. That'll be half times 8 times 4 times 15, which is going to give us a volume of 240 centimeters cubed. Make sure we have that label in there. Keep in mind for volume, it's always going to be meters, inches, feet, miles, cubed, because we're trying to determine how many cubes we can fit inside of that three-dimensional shape. All right, our next two examples are our polygonal prisms. We specifically in number 7 have an octagonal prism. So if it's any prism besides a triangular or rectangular prism, we're going to use that area of the base times the height. Now we are given the area of the base here of 45 meters squared, since we don't know how to find the area of an octagon yet. The width or height of our prism is going to be the 2.8 meters. That's going to be this distance here. So we'll just plug those in. All we have to do is do 45 times 2.8. That will get us a volume of 126 meters cubed. Keep in mind when you see the area here for area of the base, it's meters squared, since for the area we use meters squared, but for our volume answer, it should be meters cubed. Now, taking a look at the last simple example here, we've got a pentagonal prism. The area of the base is given to us, that is that 125 centimeters squared. The width of this prism is going to be 6. We also call that the height of the prism as well. So area of the base times the height, we're going to do 125 times 6. We plug that into our calculator and our volume will be 750 centimeters cubed. Now we're going to transition into doing some word problems.
All right, let's take a look at some word problems, still from this set of guided notes. Let's look at number 9. An aquarium is being constructed so that it will be a rectangular prism with a length of 8 feet and a width of 5 feet. If the aquarium is to hold 220 cubic feet of water, what should be the height of the aquarium? Again, we don't have flashing lights here saying, hey, this is a volume question, but we know we're talking about the aquarium that's a rectangular prism, so we know it's a three-dimensional shape. We know that it has a length of 8 feet. We always want to identify that information we're given, a width of 5 feet. And we know that this aquarium is going to hold 220 cubic feet. That right there represents the volume. Let me get better text here. There we go. So that's going to represent the volume of this rectangular prism. It's how much water this thing is holding. And we want to find the height. So what should the height of the aquarium be? Oops, not a very straight line there. There we go. So let's use our volume formula for a rectangular prism. Again, we know it has to be volume or surface area. We haven't talked about surface area because it's a three-dimensional shape, and because we're talking about how much liquid this is going to hold, we're talking about volume, space inside. Our formula is volume equals length times width times height. Replace V with 220, replace L with 8, W with 5, and let's solve for H. First thing I would do is do 8 times 5 and figure out what that is. 8 times 5 is going to get us 40. So we get 220 equals 40H. Solve this one-step equation. We'll divide both sides by 40, and we get a height of 5 feet. So this is a really big aquarium. Kind of like when you go to like Bass Pro Shops, for example, they have those huge aquariums in there with lots of fish. All right, let's take a look at question number 10. A children's rectangular pool holds 960 cubic feet of water. What is the depth of the pool if the length is 30 feet and the width is 16 feet? So we're talking about a rectangular pool, which is in 3 dimensions. A 2-dimensional pool would be kind of weird, right? So we've got a 3-dimensional rectangular prism here for our pool. We know that it holds 960 cubic feet of water. We're talking about cubic feet, which tells us its volume, but also we're talking about how much liquid this is going to hold. So that indicates volume for us again, and our volume is specifically 960 cubic feet. So we'll replace V with 960. We're also given that the length is 30 feet, the width is 16 feet, and we're trying to find the depth of the pool. Now that's going to represent like the height of the pool. So even though it uses the word depth, we're finding H. So same formula from the last question. Replace V with 960, L with 30, W with 16, and let's solve for H. So the first thing I want to do is do 30 times 16. So I have 960 equals 480H. Divide both sides by 480. And the height or depth of this pool will be 2 feet. Keep in mind it's a children's pool, so it's not going to be super deep, which is why we get a pretty small number there. All right, let's move right ahead and take a look at number 11. A mini fridge has a volume of 9,504 cubic inches. It measures 45 inches high by 22 inches wide. Find the depth of the mini fridge in inches. Actually just ordered a mini fridge for our basement to keep next to like our workout equipment. So pretty similar dimensions, I think, although this might be a little bit bigger than the one we got. So we're talking about the mini fridge, which generally they're going to be the shape of a rectangular prism. You're going to notice all these were rectangular prisms for the word problems. That makes sense. We're trying to keep it relatively simple for you. I'm not giving you any solve for the height of the triangular prism or anything like that. So this is about as difficult as these word problems for volume are going to get, at least for this lesson here. We know it has a volume of 9,504 cubic inches, and it's straightforward there. It tells you we're talking about volume. We have a height of 45 inches and a width of 22 inches. For this one, we need to find the depth. So basically just the missing value, which we can consider the length since we have the height and the width. It doesn't really matter. But we're going to assume this is a rectangular prism shape because we're given both the height and the width. We need to find our missing value here. So let's replace V with 9,504. That's the volume as given. We're going to leave L as it is. Again, it doesn't really matter which variable you solve for here as long as it's either length, width, or height and not the volume. Our width we're going to replace with 22. Our height we're going to replace with 45. So the first thing I did was 22 times 45. So that gets me 9,504 equals 990 L. Divide both sides by 990. And the length, or again, if you want to consider it the depth of this mini fridge, will be 9.6 inches. That's a really narrow mini fridge. We've got 9.6 inches here. I think ours is definitely deeper than that. All right, number 12, our last question, which is a multiple choice problem. I added this a few years ago because it's really similar to the question that's on your test. So let's take a look at it. A rectangular prism has a volume of 5,280 cubic inches. It has a height of 4 inches. Which of the following could be possible dimensions of the base? Well, we know we're talking about a rectangular prism here, and we're given the volume of 5,280 cubic inches. We do know that it has a height of 4 inches. So the formula that we would use is V equals length times width times height. Let's replace V with 5,280 and the height with 4. And let's divide both sides by 4. 5,280 divided by 4 is going to get us 1,320. Now, unfortunately, that doesn't tell us either of the dimensions, but what it does tell us is that the length times width, the dimensions of your base, have to multiply to give you 1,320. So what I would do is I would go into these 4 answer choices, and I would grab my calculator, which I'm doing right now, and I would take in letter or choice A, I would take 4 times 1,320, which is clearly not going to get me 1,320. So that means I can eliminate choice A. Let's go to choice B. We've got to take 44 times 30. That gets me 1,320. So that tells me that those could be dimensions of the base of this rectangular prism. I'm just going to do C and D just to prove that those are not going to be dimensions of the base. So in letter C, if I do 40 times 132, it gets me 5,280. I need that product to be 1,320, so C does not work. And then D, if I take 40 times 50, that's going to get me 2,000. And again, I need 1,320, so I can eliminate choice D as well. So B has to be our solution here, since 44 times 30 gets us 1,320. All right, so volume is pretty straightforward, especially for rectangular prisms. Triangular prisms or other polygonal prisms, a little bit more difficult. But you can see that the word problems for this, they're not too bad because they just involve that formula, capital V equals length times width times height. We'll, of course, see some more practice problems in class as well. Thanks for listening.